In the last tutorial, we talked about how to restructure our code so that we could have a class that contained the game state of our game. And so if you look here at app main, you can see that we now have a variable called main game that is of type main game. And up here right above it is where we defined that class. And this is going to be necessary because in this tutorial, we're going to add a zombie. We're still going to use good object-oriented programming and talk about inheritance. But to be able to pull off the artificial intelligence, and it's going to be really simple artificial intelligence, but to be able to pull that off, the zombie's going to have to know where the player is, and that's actually why we created this main game. So just going back here, you can see the main structure that we have here is a game object class, and this is a generic description of what a game object would be. If you look here, you can see that we have a particle class. We still have that for our flamethrower, and it inherits from game object. There was also a screw up from last time. I should have removed the render function because we can use the one that we inherited. And then if you go over here inside of player, player 2 inherits from game object and has a couple of variables, overrides, update, and everything else. And so to begin with, we should probably go ahead and talk about the zombies. We have a couple of different kinds that we're going to work with throughout the rest of this semester. And the first one is this zombie right here. It's more of a generic, very slow-moving zombie. So let's see if we can create that and bring it to life. So what I'll do is start by going to add a new file, and we'll create an empty class, and we'll just call this one zombie. And to begin with, we'll move over these using statements just like we've always done and put those at the top. Now, what are some of the things that a zombie might have? Well, if we drop down here, let's just say public float speed. And we'll set that to be 0.3f or something like that. But for the most part, that's it. Everything else for a zombie should be contained up here as a sprite or a position or something like that. Okay, so we'll come back here to zombie. We need the constructor to match that of the game object class. So let's go ahead and do that. We'll say graphics context. We'll call it context. In fact, let's go ahead before we forget and make sure that zombie inherits from game object. Come back over here, a texture2D is necessary. We'll call it text, and also vector3, pause, and one last vector3, which I believe is called vel. Okay, so let's call that base constructor again. In other words, game objects constructor, passing it all the same stuff that this class received. Pause and vel. So that looks good. That's another really common thing, by the way. Don't put a semicolon right there. That is not the syntax. Okay, on the inside of this, we do want our zombies to rotate as they follow the player. So let's make sure we do that. We'll say sprite.center .x actually gets 0.5f, and we'll do the same thing here for y, 0.5f. Okay, so believe it or not, that's the constructor. We'll use the default render. The only thing that we won't use that we inherited is update. We're going to go ahead and override that. So public override void update, and again this is going to take in that gamepad data, and we'll just call it gamepad data to keep it consistent with everything else. So the big question is, what are we going to do? Well, we know that we're going to call base update and pass it the gamepad data. And if you go back here, you can see that the way that it updates is just copies that information, the rotation and the position, into sprite. Okay, so that's what we're doing when we call base.update. Now the question is right here. So how do we follow the player? So here's the dilemma, and this is the reason that we had to stub in that other code. I don't have access to the player's position from zombie here. You can see there's no way I could type in hero or any of these other variables that we see over here in the main game. I'd like to get access to this guy right there. Notice that there's no way that we can do that. And this isn't so difficult, but it will cause a couple of compile errors the first time that we do it, almost guaranteed. So watch what we're going to do. I really need it where all of these game objects have access back to this main game class. In other words, we really need for all game objects to have an extra parameter that comes in right here as the main game. In fact, we'll just call it main game as a parameter, and we'll add an extra variable here. I'll say main game, and we'll call it main game. So the first thing that we'll do inside of the generic GameObject constructor is to say that this.mainGame gets main.game. Now this is going to break a lot of code because everything else is based off of this. In fact, if we go back and we'll look at particle, it should start to complain here. And the reason is because we didn't pass enough information to the base constructor. So let's do that for all of these guys. We'll say main.game, main.game, and we'll pass that guy off to the base constructor as well. So that should be good, and we'll go over here to player, do the same thing, say that it takes in a main.game, and pass that to the base constructor. And then looking here at zombie, zombie is another one that we need to deal with. So main.game, 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 and this one hasn't been updated, that's why it's complaining so far, main.game. Okay? So why is this good? Well, let's see what's going to happen if we come over here. It's not going to like it when I bring to life the hero, right? Because we have not passed the main game, and this is the part that's the tricky one. We're going to use the keyword this. In other words, what's happening is the main game, the instance of the main game that is running, is passing itself as a parameter. You can see that's what the this keyword is. And then that comes in here into main game. Or actually, I should say in this case, it comes into this one because we're talking about player. So let me say that again. Over here is where we bring the hero to life. The main game instance passes itself off as a parameter. And then over here, it comes in as our last parameter, which we then use like every regular parameter that we've used in the past. Okay? The other place that we need to change it is down here. You can see that we create particles. And what I'll do is to pass not this in this case, because that would be the player, but I'll pass the main game. In fact, we should have a variable here called main game that we've inherited. Okay, now if I were to try to run it and compile it, we'll surely get some kind of error. And in this case, you can see that it's not recognizing main game. So let's go back to here and make sure that it's public. Or we could technically make it protected as well, but in this case, we'll just go ahead and make it public. And we'll keep compiling until it runs. Now at this point, I can move the player around and I can still shoot, but right now I don't have any zombies. So let's make at least one of them. And we'll do that over here in app main. So I'll drop down, say public zombie, and we'll just call it zombie. Okay, and we'll create the zombie. We'll bring it to life here right after we bring our hero to life, but we don't have enough information yet. So if we were to say this, it's going to need the context, which I believe we called it graphics. And notice that it wants a texture 2D, and it wants a position and a velocity. So let's fill those variables first. So I'll say texture 2D, let's call it ztex. Gets a new texture 2D, and in this case we'll use application assets / zombie.png, passing it false. And then the only thing that we'll do, we'll reuse that velocity, this vel variable right here, but we'll redefine pause. So let's do that right here. We'll say that pause gets a new vector 3, and let's put it somewhere arbitrary, 500 over, 300 down, and 0. Or maybe let's just make sure that's on the screen. We'll put it at 400 over, 300 down. All right, so we should be able to use that information now. We'll pass ztex, we'll pass pause, and we'll pass vel. Okay, now right after that, you can see that we have update and render. So let's draw the hero last. Let's get zombie.update called, passing it gamepad data. Good, so now we've updated the zombie. And then right here, after we render the background, but before we render the hero, let's render the zombie. And the reason that I do it in this order should be somewhat obvious, that I want to render the background first and then the zombie, because of course if you render the background, it would render over top of the zombie if you reverse these. But typically what you do in a game is to render the hero last. And this will make sense a little bit later on when you actually see it in action. Now, this isn't going to behave exactly like what we want right now. And we'll go back and we'll fix the zombie in just a second. Looks like we have an error here. I should pass this as the main game, and that should fix that. Okay, now when I run it, you can see that there is a zombie on the screen. It's at 400, 300 down. Now, right now, of course, my flames are not going to do anything to the zombie because we don't have any collision detection or anything. But we do have a zombie on the screen, but it's not really doing anything. So Now that we've talked about the inheritance aspect of zombie, let's talk about some really stupid, simple artificial intelligence. And there's a couple of things that we could do here. The main idea is that we're going to compare the zombie's location with the player's location, and we can do this one of a couple of different ways. I'll show you a really common way that's not so good, and then I'll show you a more appropriate way that's a little bit more interactive. So watch what we could do. We could say if our position, in other words the zombie's position, is less than or equal to, or let's just say less than, the hero's position. Now how do we get the hero's position? We could say main game dot hero dot pause dot x. Okay, now what is this really saying? If our position, in fact I'll comment, if our position is less than the hero's position, all right, if that's the case, we know that we need to move to the right. So I could say pause.x plus equals speed. I can do the same thing. In fact, I'm lazy, so I'm going to copy these statements and paste it here. I could just say else, and then say pause.x minus equals speed. Okay? And again, because I'm lazy, I can copy these statements, and we can do the same thing for y. So if y is less than the hero's y, pause.y plus equals speed, else pause.y minus equals speed. Okay, so essentially we've changed the position of the zombie based off of the position of the hero. So let's see how this works. Now notice that it's not really facing the right way. Also notice that it's kind of coming up here at a diagonal. Now as soon as it reaches the height correctly, notice that it tracks directly towards the player. So as I move down, you can see basically it does some very poor AI, or poor movement. It doesn't face the right direction, all sorts of problems, but it does work. Okay, and again, our flamethrower doesn't work against the zombie. Okay, so you can see that it kind of moves in this 8-way direction, and that shows that the programmer is either lazy or doesn't really know what they're doing. So let's fix that. So we'll come over here. Okay, so what I'll do is say that this is artificial intelligence number 1, and we'll just comment out this whole section. We don't want it. Okay, a better way to do this would be to figure out the difference between the zombie and the player. So watch how I'm going to do it. I'll put that information into a vector called diff, and we'll say main game.hero.pause minus this.pause. In other words, we figured out the difference between the player and ourselves. Now here's a really nice feature. I could just say rot gets fmath.atan2. And again, remember, atan2 is good if you have an x and a y component. It can figure out the angle between one player and another, and that's exactly what we're doing here, but it is backwards. So what we'll do is we'll say diff.y and diff.x. Okay, so because we have that, we can use some more trig. We can say pause.x plus equals fmath.cosine of the rotation, and pause.y plus equals fmath.sine of the rotation. Okay, so look at what we've just done. We had to do all of these things anyway, but we were able to calculate the rotation of the zombie, so it's going to be facing towards the player, and we were also able to use that rotation and break it into its two parts using cosine and sine. And this is a really common pattern that you see in game development. So when I run this now, we're going to get some slightly ooh, goodness, he's moving fast, okay? So the zombie's able to catch us, but you can see, yeah, flamethrower's not working, but you can see that the zombie does actually track to the player. So what I'll probably do is to come down here and multiply the fmath.cosine of rot times the speed. And we'll do the same thing right here, times the speed. And when I run it now, you can see that we get a zombie, at least that's not going to instantly kill us. Okay? Now, the last thing that we need to do is to get a bunch of zombies on the screen. So let's come back over here to app main. And instead of creating one zombie, let's change this to a list of zombies. In fact, we'll just call this one zombies. All right. Now, what's going to change here, actually, we're going to need a random number generator. So let's create one of those called generator. And then right down here is where we bring to life all of these zombies. So let's go ahead and do that. We'll say First of all, bring our generator to life. Generator gets a new random. Okay, we only need to bring this texture to life one time. And we're going to change the position each time. So this is where we put our for loop. For int I get 0. And we could put up 10 zombies or so, I++. Okay, so that looks good. Let me tab this stuff over. Now, the position of the zombies, we don't want all of them to start at 400 over 300 down. So this is the nice feature of us having calculated screen width and screen height before. I could just say generator.next and pass it the minimum, which would be 0, and the maximum, which would be the screen width. Okay, and the same thing true here for the screen height. I could use the random number generator dot next, passing it 0 and screen height. Okay, so that looks good. Now realize that this could spawn a zombie on top of the player, but we're not going to deal with that situation right now. Okay, the other thing is, let's say that zombie here is a temporary zombie. So zombie gets a new zombie. And then we'll add that zombie to the zombie list, which we called zombies.add the zombie. Okay, so at this point we have 10 zombies that are alive, or I should say half dead, or whatever you want to call them, but they are in the list. Now the last thing that we need to do is to update the update method as well as the render method, and so we'll use the for each loop. For each zombie Z in the zombie list, which was called zombies, we will tell that zombie to update. All right, so that looks good. In fact, we will copy that code and I'll paste it right here and just call render. Okay, so that looks good, and comment out this line of code. So if we were to run it now, it looks like we have an error, and I know what I did. We forgot to bring the list to life. So let's say zombies gets a new zombie list and run it. There we go. And you can see we have a bunch of zombies coming towards the player, which is pretty good, and that they all track. Right, so it's not the best of artificial intelligence, but it does give a decent gameplay. And of course we could speed the rate of the zombies up if we wanted to. We could do the same thing for the player. We could give limited bullets. There's 1,000 different things. Okay, so there's still some parts that are missing. We still need to do some collision detection so that I can actually kill the zombies with the flamethrower. But for now, at least we have the basic structure in place. So that's it for now. We'll continue this game by adding in some collision detection as well as some additional zombies.